In this tutorial, we will build an online first contact screen using SwiftData. You'll see real records in the list in a minute, and we'll begin to design the model and also sync to Firebase later. So this is the app at the moment. I'll now show you Firebase. You can see there's no records there. So now I will create a few records. That's the first record. But I will disconnect the Wi-Fi so that the data isn't pushed to Firebase. I now save the record to SwiftData. I'll create another record. And save again. And you can see that the records have not been persisted, they haven't been sent to Firebase because we're not online at the moment. So now what I will do, I will stop the simulator and then rerun it. And then now I will attempt to push the records to Firebase, the two records, which are at the moment stored offline. So I just pull to refresh. Oh, I've forgotten to turn the Wi-Fi on, but that's a good test anyway, so you can see that it really works. I pull to refresh it again. But there's something wrong with the Wi-Fi. Has it worked now? So let's check Firebase. And now you can see, if I click on Contacts Collection, now you can see that the two records were submitted to Firebase. My record and also Fred blogs. And we can also delete the record from SwiftData, and the records will also be deleted from Firebase. Just refresh. You can see now it just includes my record only. In this tutorial, we will build the default contact repository that makes our app truly offline first. Local CRUD works instantly, and when we're online, we run one function, which is sync, to push changes and to pull updates. So the first thing we need to do is to create the following. We need to create a new file. Name the file default contact repository. Import SwiftUI. Import SwiftData. Type the following: actor default contact repository contact repository private let local contact local data source, and private let remote contact remote data source. Private let last sync key equals contacts dot last sync at. This repository is an actor, which means it's concurrency safe by default. And this also means we will not get any race conditions when saving locally and syncing remotely at the same time. So the repository depends on two abstractions, which includes local for SwiftData and remote for Firebase. The UI never talks directly to either of these. And also the last sync key, we also store the last sync key timestamp, so we can download only the changes, not the entire database every time. And that's also good for performance. So the next thing we need to do is to implement our initializer to get our variables and properties ready. So let's contact local data source and the contact remote data source are the parameters. This is a dependency injection. It keeps a repository testable, modular, and replaceable without touching the UI. So before we look at the create, update, and delete, I want you to see why this repository exists. So we need to create another function, then I can show you why. It is important sync pros. Sync has two phases: to push local changes first and then to pull remote changes. Push first is critical. It prevents overwriting local edits with stale server data. So we need to type the following: let dirty equals, it should be dirty, equals try await local fetch dirty for entity in dirty. Let status equals sync status. Choose the raw value, and then we pass in the entity sync status raw. If it's like nil, we just pass in dirty dot dirty. So what that does, we fetch anything that isn't synced yet. This is our local sync queue. This is our local sync queue to synchronize everything from Firebase to SwiftData and vice versa. So every record has a sync status that includes dirty, pending, delete, or sync. So dirty means that the record was created or edited locally and hasn't been uploaded yet. The next thing we need to do, we need to populate our DTO. So I'll just copy and paste some codes from the clipboard. So that's our contact DTO. I think there's a bracket missing. We convert our SwiftData model into a DTO, as you can see here, before sending it to Firebase. DTOs keep the network layer decoupled. Database models never leak into Firestore. So the next thing we need to do is to observe remotely, then mark sync locally. We observe remotely, so we create and update are the same operations. Then we observe locally again to mark the record as synced, and that happens on these two lines. Now I mean these two lines, on lines 40 and 42. And also the case.pending delete means the user deleted offline. When we reconnect to the internet, we will delete remotely, then hard delete locally. But in production, you often tombstone instead of hard delete to avoid bugs, and this also happens in tutorials as well sometimes. And for this line, case.sync. If it's already been synced, then we just do nothing. So the next thing we need to do is to pull the actual remote changes. So I'll just paste the code from the clipboard. Now we pull the changes from Firebase since the last sync time. Each DTO gets merged into SwiftData using upsert. Update if it exists, insert if it doesn't. And then finally we store the sync time, so future syncs are incremental. And we store the sync time using user defaults after we finish the loop. The next things we need to implement are the stub functions for the actual create, update and delete. So we just apply them here. As you can see, for the load local function, we need to implement the function try await local.fetch all false. So what that means is that offline first means we always load local first, no network required, so we get the actual data from SwiftData. And the next one we need to implement is the create. So it's similar, a little bit similar, but this is to create a new record. Local create, pass in the parameters, so name, email, and phone. Create writes locally and marks the record dirty since sync handles the upload later. Yeah, that's tongue tied saying that. And then update is similar. So I'll just copy the insert and change it to update. Change it from create to update. But the difference with update is that we use the ID parameter so that we update the correct record. And then the next one is delete, try await, local, marked, delete, and ID. Now let's compile it. In the next tutorial, we will start to update our UI so that the UI works correctly with our view models and with Firebase. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free clarity call link in the description